Hi everyone, hope you are having a great conference. The idea of this talk is to make PubSub great again, or at least we are going to try. So basically we are going to deep dive about what is PubSub, how we can use PubSub in Elixir, and then see some examples so we can understand the concept a little better. First thing first, a little of introduction. I'm Alvaro, I'm from Uruguay. I'm a computer engineer, and I've been working with software for almost 12 years. The last year was wearing Elixir, but before I was a Java developer and also a Salesforce developer. I was also one of the speakers at ElixirConf 2024 in Orlando, and in Coding America this year, so I really enjoy fostering the growth of the Elixir community, and I'm really happy to be here. So just want to say thanks to ExMex for giving me this opportunity. Yeah, let's start. But first, trivia time. Let's try to answer to the following question. So, which of these was the first example of the core idea behind PubSub? And the options are: number A, Twitter; number B, television broadcast; number C, newspaper subscriptions; and number D, Roman town criers. I hear B, I hear A, no problem. B, okay. The answer is number D, you are correct. So, in the ancient Roman Empire, there used to be a town crier that used to announce the news in the forum. So, those citizens that wanna receive those updates needed to subscribe by showing up in the street. So that's PubSub. You have one information and multiple recipients. So as you can see, the pattern is pretty old, it's pretty ancient, but the implementation is modern. So now you have a totally random information that nobody asked for, but you can start a good conversation using that. So this is the agenda for today. We're going to start talking about what is PubSub. In the second part, how we can use PubSub in Elixir. And the third part, the last one, we are going to see some use cases to try to understand the concept a little more. So what is PubSub? It is a message design pattern, so it is used in distributed system for asynchronous communication between the different components. Although it is based on earlier messaging paradigms like message queuing or event broker, it is a more flexible and scalable solution. It was built for dynamic scaling, so PubSub was created to support the expansion of information systems. So in the pre-internet era, the systems were designed with a fixed or predefined resources that could be easily adjusted based on demand. However, with the expansion of the internet and web-based application, fueled by the massive adoption of mobile and IoT devices, systems needed to scale dynamically. So PubSub emerged as a key solution, providing things like elastic scaling, efficient load distribution, and real-time responsiveness. It is also capable of meeting scalability requirements because pooling is not needed since it is a push-based delivery, so consumers don't need to ask for new information all the time. It avoids overload the design of our architecture with too many components, so the system can scale efficiently without adding unnecessary complexity. And it also replaced the point-to-point connection with a single connection to a message topic, which by the end of the day simplify a lot the communication and the integration between the different components. Pretty cool. This is the PubSub architecture. So PubSub provides a framework for exchanging messages between publishers, the entities that create and send the messages, and subscribers, the entities that receive and consume the messages. The publishers don't send the messages directly to the subscriber. They're going to use an intermediary component called message broker. So the message broker will be grouping messages into entities called channels or topics. So whenever a new message arrives at a specific topic, will be delivered to those components that are subscribed to that topic. And yeah, this is the architecture. Simple, yet effective. Okay, in the second part, we are going to try to unveil the mystery about how we can use PubSub in Elixir. In order to do this, we are going to use the module Finnic PubSub. This is a real-time publisher subscriber that we have available to use in Elixir. It is a distributed real-time messaging system that will allow the process to broadcast the messages and also receive the messages. It allows scalable message broadcasting across nodes, which is very important and crucial in real-time applications like broadcasting, live updates, among other use cases. And it also has support for different adapters or backends. So what is the idea about this? We can see Finnic PubSub by like an abstraction that will allow the processes to communicate using the PubSub messaging pattern. Then we are going to have the underlying implementation or the concrete modules known as backends or adapter, the one that will be provide the actual implementation for message distribution and will define how messages will be propagated across the processes. So that's the idea about the backends. So let's take a look about the different adapters that we can use within Finnic PubSub. The first one, Finnic PubSub PC2. This is the default adapter, and this adapter will be sending the messages using distributed Elixir. Just to clarify, PC stands for process groups. I know at first it can be a little tempting that it's Postgre, but it's not because it has its origin from Erlang. This is a screenshot from the Erlang documentation about the PC2 module, and the way that this module will be sending the messages is the following. The message can be sent to one, some, or all the members of a group. So imagine that we have a group called ExMex, then we are going to have a bunch of processes that belong to that group. But PC2 by itself doesn't provide a functionality to broadcast the messages, so what this module will be doing is to grab the processes that are members of that group and then send messages to one or more group members. So by the end of the day, Finnic PubSub will take that module and wrap the functionality to add the necessary logic to broadcast the messages. This is the PC module. This is the last version because starting from OTP, PC2 was deprecated and was removed from OTP 24, so the last version is the PC module. It is quite similar to PC2, but we are going to have some improvement. For example, when we work with large cluster, or some enhancement for the logic related to the scalability when joining and leaving the groups, but it's almost the same functionality. This is the commit that add the PC into the Erlang repo. Here you can find all the information. For example, this was added in February 2020, and maybe the font is a little small, but this section is comparing the difference between PC and PC2. We already mentioned some of them, like the improvements when we work with large cluster, but here in this commit you can have all the information. So at this point you might be asking the following question, and if you're not, no worries, I am, so we are gonna have it anyway. So the question is the following: why don't PC or PC2 implement broadcasting? Well, in my opinion, it's a matter of simplicity, because by the end of the day, what PC will be doing is just focus on group management, and then the error handling and all the related logic about message sending will be delegated to the user. Because, for example, what happens is there are partial failures. So let's say that we are sending a message to one node and it succeeds, but another node, if we send the message, fails. So we should retry, or we should just send a report of the node that failed on the message sending. Network partition. So let's say that we are broadcasting, but some of the nodes are reachable. So how long should we wait before timing out? What happens if a process dies in the middle of the broadcast? We can assume that all the broadcasts fail. Well, by the end of the day, what PG, the module of Erlang will be doing is just a separation of concerns. It will focus on group management, like listing and retrieving the processes that belong to the group, and then all the logic related to message sending and error handling will be delegated to the user. The second adapter, Finip PubSub Reddit. So in order to send the messages with this adapter, we are gonna using Redis under the hood. In order to do this, to use this module, we need to add the Redis dependency in our mix.xs file in the project, and also have a Redis server up and running. Probably one of the main drawbacks of this approach is that the Redis act as a single point of failure. So if we don't have any cluster strategy or something like that, if the backend is down, then we cannot send the messages. And the last adapter is Finip PubSub adapter. This is like a custom module that we have. It is a behavior to meet any specific need of our project. And since it is a behavior, we need to implement some callback. For example, the non-name, the child spec, and all the broadcast function. The idea of this adapter is to meet some specific requirement of our architecture that maybe we cannot achieve with the other two adapters. So, what are the steps I need to follow to set up PubSub? Well, very simple. We need to add Finip PubSub as a child of the application supervisor. Then we need to subscribe to PubSub, providing the name and the topic. Then we need to execute the broadcast. We need to send the message using PubSub. And then we need to add the handle info message to basically do some stuff after we receive those messages, okay? So let's see some use cases to understand this concept a little more. We're going to be seeing two examples. One for Shen server, we are going to be share state using PubSub across nodes that are connected using libcluster. And the second example is for front-end lovers. We are going to make something with LiveView. So basically, we have a LiveView Fire component and a live component, a child, the one that will be sending messages from child to parent. So let's execute some code. So what can be wrong? Okay, this is the Shen server example. It's just a very basic application. In the application.ex, we are going to have the libcluster topology. We are going to use EPMD for node discovery. And then between the children of our application, we just have the supervisor of libcluster. Here we have our friend, the PubSub module. And then we are going to have a Shen server. Just to clarify, the two examples that we're going to see, imagine that you love cars, any kind of car. So we are going to find a way to organize the cars that we have in our garage by its brand name, okay? That's the idea for the both examples. So in this case, we have a very simple Shen server. In the start link, nothing fancy. We're going to start the initial state as an empty map. Then we're going to have two public functions, one to get the brand counter, so providing the brand of the car, we are going to figure out the amount of cars that we have in our garage. One to increment the brand counter. Then in the init function, instead of just returning OK state, we are going to be triggering the handle continue. So making a pattern match in the setup PubSub. What we are going to do here is to subscribe to PubSub. So every time we spin up a new node, a new Shen server, all the Shen server are going to be subscribed to the same PubSub and the same topic. Then in terms of the callbacks, we are going to have a handle call to get the brand counter, and the handle cast, the one that will be incrementing the amount of car given the brand. After we update the new state, what we are going to do is make a broadcast of that state. So this way, every time a node updates its state, it will be synchronized between all the nodes that are connected using live cluster. Then, as we can see, as we previously saw in the slide, we need a handle info. So every time a new message is broadcast, we are going to make the pattern matching in the handle info, and we are going to be updated the new state with that counter. Okay. So let's start 2 nodes. In this case, we can see, for example, that we have connectivity between the nodes. For example, in the node 1, we can see that we're connected to the node 2 and the other way. Okay, and in this case, we can make things like, for example, we are going to start adding new cars in our garage. So let's say that we have 2 Hondas. We can see the other node is receiving the message, so we are synchronizing the state. In this case, we have 2 Hondas, so in the other node, if we execute the get brand counter and we provide the brand name, and in this case, we are going to see that we have 2 Hondas. Okay. In this case, we are using the default adapter. We are using the PubSub, the PG2.1. But let's say what happens, for example, if we switch to the Redis one. In order to do this, remember that we need to have a Redis server up and running. So I have one. Let's execute the Redis CLI, and let's also execute the monitor command so we can see the messages that the backend is receiving. Okay. So in this case, we can see that the backend is receiving the subscribe signal. And also, we can see the other node is receiving the subscribe. So in this case, both nodes are subscribers. So if, for example, we increment the brand counter, we can see that the backend is receiving the messages. In this case, if I shut down the Redis server, we can no longer send messages, and this is the main drawback that I previously mentioned. One of the things that I want you to see here is the magic of using the default adapter, because when you use the default adapter, the PG one, every node acts not only as a subscriber or as a publisher, but it's only part of the infrastructure, is what will gonna give us the connectivity. That is part of the magic of use the default adapter. So let's see some front-end example. Continue building this great cars application. In this case, we are gonna have some UI to visualize a little more the cars that we have in our garage. So in this case, we are gonna see just the most important part of this mini project. This is the LiveView page. In the mount function, after the socket XConnect, we are going to be subscribed to PubSub. Then we can fetch the cars that exist in our database, and then we just add the cars in the stream of our socket. In terms of the render, we have the live component. This is the child component that will be in charge of handling the logic of the form that we have to create new cars, and then just iteration over the stream to show the information of the cars. So here we have a function component, the one that will be showing the brand of the car, the model. Also in the LiveView page, we can see that here we have the handle info. So every time the child will be sending a message using PubSub, then the father will be making the pattern match in the handle info, and we can update the stream accordingly. So a new car is created, we are going to update the stream, the same when a car is deleted or when it's updated. Okay. In terms of the child component, the live component, in the render function, as I mentioned before, we have the form to add new cars. So we are going to have 2 inputs, one for the brand of the car, one for the model. So every time we create a car, we save it into the database and we call our function broadcast. So every time a new car is created, then we're going to be sending a message to the father. So let's try to start this server, and let's see how it is behaving. I will start the front end. I know front end is my passion, don't even mention it. Okay, in this case we have two different windows, so both browsers, those tabs are connected using PubSub. So let's say I add a Ferrari. Let's say that I also add a Honda. In this case, the S2000. But I can also do the same in the other window. So I got Suzuki. For example, let's say that we sell the Honda because we are running out of money, and in the middle of the night someone steals our Ferrari. So if we delete the car, then we can see real updates because we need to say thanks to PubSub. Okay, let's sum up and reflect about what we learned so far. So, Finite PubSub delivers scalable real-time apps, fault-tolerant messaging, and seamless integration with Xen Server, LiveView, and distributed nodes. And best for distributed system needed dynamic scaling, decoupled component, and instant responsiveness. So, with nothing more to add, I just want to say thank you for being here and have a great rest of the conference.